This is lesson 2.1, greatest common factor, and we're on page 32. And let's go ahead and read this, read example 1, check it out, and then try the problems at the bottom of the page. Finding the greatest common factor. One way to find the GCF of two numbers is to list all their factors. Then you can identify common factors and the greatest common factor. Example 1. A baker has 24 sesame seed bagels and 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. What is the greatest number of boxes that the baker can make using all of the bagels? How many sesame bagels and how many plain bagels will be in each box? I want you to pay attention to a clue here. What is the greatest number of boxes? Well, in order to figure out the number of boxes, you're going to need to figure out how many of each go into those boxes. That's a greatest common factor question. So pay attention to the fact that when you see a question kind of worded like this, it's going to be a GCF or greatest common factor question. So check it out. Step number 1 is to list all the factors of 24 and 36. The factors of 24 include 1, 2, 3, 4, 6, 8, 12, 24. The factors of 36 include 1, 2, 3, 4, 6, 9, 12, 18, 36. The blue circles indicate that those numbers appeared in both lists. 1 is a factor of 24 and 36, as is 2, as is 3, so on and so forth. The greatest number that's circled in both lists is 12. So therefore, the greatest common factor of 24 and 36 is 12. That's not the end of the question, though, because after you figure that out, what you're supposed to do is go back and remember what these questions represented. It was 24 sesame bagels and it was 36 plain bagels. So after you figure out the GCF, you will divide 24 and 36 each by 12. And you'll end up with 2 sesame bagels and 3 plain bagels. And you get those numbers by dividing the number of those bagels by the GCF. All right, let's go ahead and practice a couple. Well, there's a reflect question first. It says, what is the greatest common factor of two prime numbers and give an example? Let's go ahead and think of a couple prime numbers and then figure out their GCF. So a prime number would be something like 5. And let's go with a little bit larger one like 17. Well, the factors of 5 are 1 and 5, and the factors of 17 are 1 and 17. So this is a nice review. The definition of a prime number is a number that has only two factors, 1 in itself. Well, 5, it doesn't appear in the 17 list, and 17 doesn't appear in the 5 list. So what is the greatest common factor of 5 and 17? It's 1. Let me try two different ones. Let's try 13 is a prime number, and 31 is a prime number. Well, the factors of 13 include 1 and 13, and the factors of 31 include 1 and 31. And I notice once again that the greatest common factor is 1. So at this point I can probably draw the conclusion. The GCF of two prime numbers is 1. All right, let's move on. So your turn at the bottom of the page. There's 3 GCF problems. 2 are just kind of basic, and 1 is a word problem. So let's check those out. What I'm going to do, sorry about that, went too far. What I'm going to do is make a little whiteboard here, because I like to show my work. Make a little whiteboard, and I'll move it when I need to. So for 3 and 4, it says find the GCF of each pair of numbers. And what I like to do is, at least at first, is I like to list all the factors. So I list them like this. I put the factors of 14 here and the factors of 35 here. And if you need to use a multiplication chart, that would be okay. The factors of 14 include 1 and 2 and 7 and 14. And the factors of 35 include 1 and 5 and 7 and 35. And so I look at both lists. 1 and 1 are in both lists. 2 and 5 are not. 7 and 7 are in both lists. And that's the highest number there. Greatest common factor stands for the greatest number common to both lists. The answer is 7. So let's check out number 4. The factors of 20 and the factors of 28. The factors of 20 include 1, 2, 4, 5, 10, and 20. The factors of 28 include 1, 2, 4, 7, oops, I missed 5, 5. No, it's not 5. I don't know what I was thinking there. I was thinking of 20, actually. It's 1, 2, 4, 7, 14, and 28. And the greatest number that's in both lists would be 1 is in both lists, 2 is in both lists, 4 is in both lists, 5 no, 7 no, 10 no, 14 no. So it looks like it is 4. The greatest common factor of 20 and 28 is 4. All right, I need to clear this, and I need to move my whiteboard because I've got a question below that we need to answer. Number 5. The 6th grade class is competing in the school field day. There are 32 girls and 40 boys. 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. What is the greatest number of teams that can be formed? How many boys and how many girls will be on each team? I want you to pay attention to the fact that this is very similar to the bagel problem. And on the bagel problem, what they did was they started by listing all the factors of 32 and 40, so we could do the same thing. And then once they found that factor, that GCF, then they divided both 32 and 40 by the number of teams. So let's check this out. I need to move this down just a little bit. In fact, I'm going to clear it, move it down just a little bit so I have room for my answer. So we've got the girls team, which is 32, and the boys team, which is 40. And 32 includes factors of 1, 2 goes into 32, 3 does not, 4 does, 5 does not, 6 does not, 7 does not, 8 does. And that kind of tells me I'm at the end of my pairs here because it's going to be 4 times 8. Remember that little rainbow method I showed you? And then this can be 2 times 16. And this can be 1 times 32. So the factors of 32 are 1, 2, 4, 8, 16, and 32. 40, the factors include 1, 2, 4, 5. 5 times 8 is 40. It's 4 times 10. It's 2 times 20, and it's 1 times 40, and that's all the factors of 40. And so now what I have to do is carefully examine my 2 lists and look for the highest number that appears in both. And I think I'll use a highlighter here for neatness. 1 is in both lists. 2 is in both lists. 4 is in both lists. 5 is not. 8 is in both lists. And that's the highest number. So we got to pay attention to the fact of what we just answered. The question right here, what is the greatest number of teams that can be formed? It's going to be 8 teams. Now, including this word teams in my answer helps me figure out what my next step is. If you think back to the bagel problem, once you figured out that you could make 12 boxes of bagels, what you had to do was divide the number of sesame and plain bagels by the number of boxes. We need to do the same thing here. 8 teams can be made, but how many girls would be on each team? Well, there was 32 girls. Divided onto 8 teams would be 4 girls. And we have to do the same thing for the boys. We had 40 boys divided by 8 teams. That's going to be 5 boys. And we should probably write a short phrase. So the answer would be 8 teams, 4 girls, and 5 boys on each team. That is the correct and a fairly well-written answer.